I don't know. Why are you laughing?
Oh,
Man,
Lily.
I never start my shows probably because of you. Anyway, hi guys. Hi, I'm Looney. That's Lou.
Hello.
How are you?
All right in yourself, Lily?
I'm fine. You see, his face is even pink, and I don't know. What are we doing for the messages today?
Well, we got to carry on with digestion, right? So we're going to have a look at absorption and that thing called assimilation. All right.
Okay, cool. You heard it, grade 11s. I hope you guys are excited. How to get a hold of us. Facebook.com/LearnExtra. Twitter is @LearnExtra. How to download the show notes, the videos, and the schedules is learn.mindset.co.za. And I hope you guys noticed. I'm doing it slow now because Lou was complaining that I always Facebook, Twitter. So you see, today I'm calm, I'm relaxed, I'm telling you everything step by step. So I hope you guys got that. And if you want to win yourself this awesome Casio calculator, all you need to do is follow the link on our Facebook page for the entry form. Fill in everything, your details, answer all the questions. But remember, guys, you have until Friday at 12 in the afternoon. So you can just chill now, watch the show, and then maybe at like 12, you like wake up and you can't sleep. Like, oh, let me enter. But remember, Friday, 12, it's over, it's done. You can't enter anymore. Congratulations to Gift. You have won yourself this awesome calculator, but I'll keep reminding you that you have won throughout the whole show in case you forget.
Now, have you noticed how she says it's my fault she's doing it slowly? Well, you know what I was
Because
thinking?
you were complaining.
No, I agree, and I'm with you. But remember, we always got new people watching us.
Oh, yeah.
You see, and I'm thoughtful. Well, am I right or wrong, Lini?
You said me right. You see, thing is, I'm so used to.
That happens.
Yeah, anyway.
Now, what I've done is I brought a friend along, right? I must introduce you. His name is John, right? I call him John. There he is. There's John. Right, now we're talking about digestion and all of this, and I thought it would be nice to show you what it looks like. Now, I couldn't put a real person on here because I'd be in trouble, right? But wait, we'll get the real things in here and have a look and play around a bit because Looney asked me so nicely. Right, Looney?
Yes.
Now, let me tell you why I know that this is a male, because you've noticed I called it John, is because he loves Looney. Right? And for many years he's loved Looney. And you know how I know is because he's given his heart to Looney. And she never gave it back. So he's missing a heart. Right, so what I'm going to do is we're going to go through the digestive system. It's true, hey, Looney.
I don't know what you're talking about.
Trust me, I know what I'm talking about. Right, so what we're going to do is we need to get underneath here to start having a look at the digestive system. So if you want to start right at the top, we've got, see my face, there we go. Hey, Looney, that looks fine. We've got the mouth, and then we go down, we get to the esophagus, which is here, and then we've got these big things that are in the way. Right, so what I'm going to do is I'm going to unclip it. There we go, come on. And I'm going to get rid of parts. So I'm going to get rid of these big things that take in the oxygen, the lungs, right? There they are. Put them aside. I want to have a look at what I see here. Now, you'll notice the heart is missing. Looney did not give it back, right? So that's what we're missing. You'll notice this nice big covered part. Now, this is the part that we are interested in, right? This esophagus, it comes down, and then this part. Okay, over here, this big, beautiful thing. Now, when I do a live show, you'll see how soft it is. I'm going to pull it out, right? And we have a look at this. This is called your liver, okay? If you have a look at it, okay? There's a little bladder there. There's a little green thing. Can you see it clearly? Okay? I'm not going to tell you what that is. I want to know from you. So send Looney. Tell me what that little green thing is. Right, as quick as possible. And then, Looney, can you remember doing this with me?
The cutting up
Yeah,
of
can
the
you
parts.
remember cutting it?
Yes.
And feeling it in your
Yes.
fingers? We're going to do it again, hey?
Yes.
Definitely. Now, this is the liver. Did you see where it stands? Right? It's up here, and it's forced in. It carries everything nice and tight. It's in this part of our body, right? Nice and tight. And the liver's nice up on top, and I can pull that out. Let's get rid of everything. Now we're having a look at this beautiful thing. This is called a stomach. Now, you'll notice that there's a thing over here, okay? That's a round muscle. It's called a sphincter, right? Now what happens is the food comes down the esophagus and into this pipe here, into the stomach. And then the stomach closes the sphincter and it grinds it like this. It moves like this, crushing and grinding everything on the inside, right? When it's ready and it's mixed with hydrochloric acid and everything like that, it moves on. Where do we move on to? This blue thing. Hey, Looney, we move on to the blue thing, hey?
Mm-hmm.
No. Look at the difference. How big is the blue thing?
It's big.
It's big. So what this blue thing is actually the large intestines. The large intestines is the blue running around it. So let me get it out of the way. Okay, just so that you can see. That is the small intestines. Now the small intestines, if you watch how coiled it is and it's bunched up, it looks like you've taken a big piece of string and moved it up together, right? And that there, nice and compact, it needs to do that because it needs to go all over the place and absorb. It's trying to absorb everything, right? Now in humans, how long do you think this is, Looney? The small intestine. So I'm going to take it out. How long do you think this part of the digestive system is?
Very long.
Take a guess.
Hayi kaloku.
Take it. What do you have to lose?
In centimeters. In meters.
Whichever you feel like.
It's not a meter.
You reckon it's less than a meter?
Yes.
Because a meter, if you think about it, a meter's about that much, right?
Oh, maybe.
Not to my fingers or toe. So think about it.
Maybe it is a meter.
How much do you think? Come on, give me the best.
A meter.
Estimate. You reckon a meter?
A meter and a half. 2? 2 meters. 3? Hayi kaloku. Say 4.
Carry on.
5.
Carry on.
No, it's bigger than 5 meters.
7 meters. That's what
In a
this is.
person.
7 meters is inside your stomach here. 7 meters. That's a lot of intestine.
Yeah.
It's got to be long, which where all the absorption takes place. Am I right? Hey, Looney? Now,
Yeah.
interesting fact, before I carry on. That is the small intestines. Now I'm looking at the large intestines, which hangs, let me put it the right way around, which is that piece there. All the blue. Okay, it comes up and it goes round and goes down and into the anus over here. Right? That's what it looks like on the inside. Okay, it's just smooth muscle, right? And that, remember, it goes to peristalsis. You can look at it in here or in here. It's quite nice. Yes, we have a pin in the middle, but we've got to hold it with something, right? Now, that there, that goes to peristalsis. Can you remember? Okay, and the peristalsis moves it along all the way back to the anus, which is right in the back over there. So I'm going to remove this. Let's see if we can get it. Okay, there it is, there it is. Goes all the way to there, to the anus, all the way through. Now, look how big this is. Okay, here it is. I'm going to put it here again. Let's see if I can get it in. That's all it is. It starts, let me see, from here, okay, and it goes up, it goes across, goes down, and goes in there, and it stops. So which is more? Looney, which has got more? Definitely this one. So 7 meters, not that long, right? Now let me give you a little question. The blue whale, this is some, you don't need to know this. This is just some fact to make it interesting, right? Looney, a blue whale, right, is not that big. It's about 60 meters, right?
And that's not
60 to
big.
It's about 30 to 60 meters.
Yeah.
Big, it's big, but it's we know a blue whale is the biggest thing out, right? Take a guess how long its large intestine is. Not its small one, it's large. Take a guess.
If it's like,
Take a wild guess. What do you have to lose?
10.
You reckon 10? Okay, 10. Now, are you sitting down?
I'm sitting down.
Are you sure you're sitting down?
Yes.
Try 4.8 kilometers.
Really? Kilometer.
Kilometers. 4.8 kilometers is just a small intestine. That's a nice,
man.
interesting fact, hey?
No.
How cool is that?
It travels.
It travels, right? Okay, so hopefully you enjoyed this. Yeah, the last thing that can come out is just the bladder. Okay, but that's not what we're doing now at the moment. I hope you enjoyed Bob. He didn't mind stripping for you completely, all the way down to nothing. Okay, you saw his insides. Now, stay tuned. Soon we're going to do a complete real thing, and Looney's going to get her hands dirty. Can't
When?
wait.
Today?
Not next week, the week after.
Oh.
Not next week, the week after. Let's see if I'm going to try and promise. Well, I'm going to promise I'm going to get it done. How's that?
Cool.
Definitely do it.
Yes.
Right. So I reckon we go back to the board, huh? And start doing some work. Right. If we're back here, what we need to do, human nutrition, absorption, and assimilation. That's what we're going to do today. Okay, firstly, let's have a look what we're going to learn in this lesson. Okay, we're going to have a look. Okay, we're going to have a look. We're going to examine and understand absorption, which is very important, right? We're going to define absorption. Let me change the color here, because white and white normally goes well, but it's fine. We're going to define absorption and describe where it occurs, so what part of the body it occurs. Okay, then we're going to study the structure of a villus. Okay, those things are very important. They're one of the key things that make us absorb things. There's a villus, right? We're going to look at assimilation, right? We're going to describe how it occurs. We're going to understand it, okay? Then we're going to have a look at the very strange structure of the hepatic portal system, right? And we're going to define the different functions of these things, okay? And then we're going to examine and understand, as I said, assimilation. Nice and easy. We're getting all nice and gritty in there. Now, please remember, if I don't get through all that stuff, the notes are on the web. Am I right, Looney?
Yes.
It's all there. Okay, so I want to try to bring you as many questions as possible so that you can understand how we're going to ask things. Yes, I do explain it as we're going along, so bear with me if I don't get to all the notes. Right. Firstly, before we go, I need to have a look at this thing, the challenge question. Okay, very important. The challenge question. Describe, here we go. Now, can you remember we looked at carbohydrates, proteins, and fats and all of that? Looney, can you remember? So you remember what lipid is?
Fat.
Clever girl. You see, she's getting there. Right? We're going to describe the process of digestion and absorption and assimilation of carbohydrates. So now I've put in a specific thing. So now we've got to look at the enzyme that breaks it down. Don't forget. Right? Very, very important. Okay, first thing we're going to have a look at, absorption. Absorption is the process. Okay, it's defined as the process of taking something and breaking it, making it small, and taking it into the blood system. Okay, because that's what it is. We're absorbing it into the body. So let's see. Absorption is defined as the process where the product of digestion, in other words, what this plus this plus this is, right? Is made into smaller molecules moving through the walls of the small intestine into the blood vessels. So it's literally, when it's in the small intestines, it's literally going from the intestines into the blood. Okay, that's what its definition is. Then, the absorption can occur in certain places. Okay, it does occur in the mouth. You'll notice a lot of people suck sweets and all of that, right? It absorbs in the mouth. It does do it in the stomach, very slightly. So not that it doesn't. It does do it in the stomach, very, very slightly. Okay? It also happens in the large intestines and, of course, in the small intestines. Okay? Majority of it happens in the small intestines. You know what I'm talking about, Lini? That's why the small intestine is so long, right? She's
Majority of absorption of what?
You see, I was right. You're going to get caught out on this show, girl.
Okay.
Right? Majority of absorption takes place in the small intestines.
Yes,
right? So majority
I
of
was
it.
right.
Yes. You just said, and then when I asked
And then I said majority of absorption. What are you talking about?
happens in the small intestines. It's very easy, right? Remember that most of our water, right, is happening in the large intestines. That's where we do the water. That's why if you have a runny tummy, it means that we're not absorbing enough water in the large intestines. That's very bad for you. Make sure that you drink a lot of water. Right. And then, for absorption to occur, it's very important that we have specific things, right? We need to have a large surface area, okay? We need to have thin walls, and we need to have a lot of blood close by. So let's have a look at what I said here. Okay, absorption occurs properly. There are certain requirements that are needed in the small intestines, right? So, first thing, there must be a large surface area. Exactly what I said, right? Then, there's got to be lots, oh, here we go. There's got to be lots of nutrients that can be absorbed. I mean, if it's not going to be, there's not a lot, it's not going to be absorbed. It needs all that it can get, right? It needs a lot of stuff, okay? The surface of the intestine must be thin. Right? You don't want to go through, it's like going through a brick wall or a little plastic soft wall. You know, thin walls or thick walls. The thinner they are, the quicker they absorb. Right? Do you understand? If I took a sponge and I held it to a nice thick sponge, and I poured water on it. It doesn't pour and fall through immediately. It pours, and you can see it filtering down and then goes through. If you have a little cloth, as you pour it, it'll pour out immediately. The thinner it is, the quicker absorption takes place, right? So it needs to be thin, right? It needs to be small molecules. So that's why the teeth comes into play, to break it all down. That's why we have the peristalsis movement that squeezes it all the way down. That's why the stomach churns, right? That is why the large intestine and the stomach adds, and the mouth, of course, adds enzymes to break it down, to make it into smaller molecules so we can absorb it, right? So we need that. There must be a good blood supply. Luni, why must there be a good blood supply? Should I help her out?
Yes.
Okay. Luni, if you wanted to go to Cape Town,
Yeah.
you need a lot of people. You need a lot of cars, right? If there wasn't a good bunch of cars, would you all get to Durban?
Cape Town.
Cape Town or wherever?
No.
No. So what is the blood?
The car.
The transport, right?
Transport.
So why do you have to have a lot of blood, a good blood supply? To carry the nutrients.
Carry
That's
the
it.
nutrients.
You can have a lot of nutrients. If you don't have blood, it's going nowhere. Huh?
Cool.
Slowly. Hey? Gonna go nowhere. And then, of course, very important, the molecules inside the intestines must be in close contact with the surface. It cannot be absorbed if it doesn't get, it cannot be absorbed if it's not close to the surface. If it's in the middle and it can't get close to the surface, it is not going to go anywhere. Right, so that was just a quick having a look at absorption. Right. Rini, I think we need a break, hey?
Mm-hmm.
Let's see what you've got.
All right. Gift Njabeleng, congratulations to you. You've won yourself this awesome Casio calculator. Mindset is with that said, let's take a very quick break, but we'll see you straight after this. Hello, welcome back, guys. This is my new friend, Stomach.
Stomach.
and then remember when Lou asked you what this green part is? This is the liver, and in this green part is the gallbladder.
That you find a specific thing inside. What is it?
Hmm?
No, well, you've got...
Gallbladder.
We've said gallbladder. Now, what does the bladder, because the bladder store things, what do you find inside the gallbladder? So I like putting questions out as we go.
But yeah, asking for help.
That's it.
Yeah, what do you find inside the gallbladder?
No, that's a good question, Lou.
Where does bile go? Am I right? Oh man, bile. Listen over.
Where did you come up with that word now?
I don't know. Like I just thought of it. Bile. No,
I'm
no
impressed.
one whispered. Actually, someone whispered. You find a gall. The people we have. Anyway, listen over from me.
I'm impressed, Ludi. I'm really, really impressed. That was good.
There's
It's not too
something.
bad.
There's something in here.
There's something in there somewhere.
Yeah.
We'll find it one day.
One day.
Two brain support.
Yeah.
Two brain cells, hey, Ludi?
Yes.
One dead, one on life support. Never. She's got millions. Right.
Oh
so
my
let's have a
gosh.
look at it. You do love me, Ludi.
Yes.
It's plain and simple. Right. Let's go on to questions. And as we go through questions, we'll explain things. Okay. It says here, what is the difference between absorption and assimilation? Right. So let's go through it quickly. Absorption we spoke about just before the break, right? Told you it's breaking it down into smaller molecules, taking it into the small intestines and the large intestines, and taking it into the blood, right? That is absorption, okay? Very important. That's all absorption is. But that doesn't mean that every single organ's got what it needs, does it? Hey, Luni? It doesn't mean that. If I've just absorbed it into the blood, right, that just means that it's going around in circle, all the way. It goes from the heart all the way down to the toes and back to the heart and all the way back down to the head and all over. It's going nowhere. Now, assimilation is what happens when it becomes part of the body. So now we're taking all that stuff and we're taking it into the organs. That is assimilation. Right. So let's have a look. Assimilation. Okay. Firstly, absorption occurs when food enters the body as food molecules pass through a layer of cells, remember, in the small intestines, in the large intestines, when it comes to vitamins and all of that, and water, still absorption, right? Stomach, mouth, slightly, right? Into the body tissues, right? Into the body. This occurs with small intestines, which has many villi. Ooh, a villi. What is a villi, Luni?
A what?
A villi. Isn't it that village where they have these beautiful houses and you have the river running past it? Huh? Yeah, no, I'm talking rubbish.
I don't know what you're talking about.
Talking absolute. I just see, just to show her that I'm still the man, that she's still got to learn from me. Right? Villi is a small little protrusions that come out of the wall of the intestine. So if I had to, let's see, I'm going to pull this down. There's another question for you, but I'm going to touch here. I'm going to give you a little bit more space. So watch carefully. If this was the wall of the intestine, right? Now, those are the walls. I'm just going to draw one, just to get you going, just slightly, right? That is a single wall. Now, for absorption to take place, it's going to take quite a bit, but I want to increase the amount of absorption. So what do? Is I put this villi in it, right? And it's not a single cell. It's not like a root hair, where root hair is a single cell. This has got many cells. So what we're going to do is we're going to take an eraser. I'm going to erase that part of it, okay? Take the pen back up, and what happens is it comes like this. If I can get there, there we go, there, up, and back down, and there. That's what it looks like. Now watch how it increases the surface area, and it does it all the time. So it's doing this. That's what the villi do. Just increasing surface area over and over and over again. And those little things have special glands like the Bremer gland and the crypts of Libacune and all of those things that become very, very important, which we'll talk about just now. Trust me, right? And that increases surface area so that you can absorb more. Right, so that's what the villi is. So you need villi for this part. Very important, okay? Then it says that's a specialized tissue. Then we have a look at assimilation, right? Now, assimilation occurs when the food molecules become part of the body, okay? Becomes part of the body means it's inside. We use it. It's inside the cells, everywhere we need it. It's what we use it for. That's assimilation, right? And if we have a look, therefore, absorption happens and it is followed by assimilation. So, absorption, take the food into our stomach, right? Gets absorbed by the small intestine, gets taken around to the organ, and then assimilation takes place when it goes into the organs. Hey, Luni? Happy? Good. Can you explain that in English now?
No, it's fine. You just did it.
You gotta love it, don't you? Right. Now, let's carry on. Explain how the structure of villus is related to the role in absorption and transport of products in the digestive system. So now we're having a look at what I was trying to tell you. Remember I was telling you about this villus and what it looks like, right? Now, first of all, it needs, if I'm looking at it, just thinking off the top of my head, for absorption to take place, right, I need something very thin, yes? Okay? Now, if something is very thin, it moves through it quickly. Yes, Luni, hey? I hope you're listening, because I'm going to ask you all the time now.
Okay.
Okay, so concentrate.
Okay.
If, with thin walls, something's going to move through it quickly, right? Luni?
Yes.
Good, right. So it's going to go through it quickly. Now, if I have 10 people on this side, and there's only space for 10 people on that side, let's say I've got 20 here, sorry, and I've got only space for 10 people that side. To be able to go, excuse me, through it, and then stand on this side, it's going to get packed, isn't it? Right? So I need something to take them away, am I right? So a good blood supply, so every time I step across, I'm gone. So it looks like it needs another 10, and needs another 10, and needs another 10, which means as one comes in, it gets taken away immediately. Whereas if there was very bad blood supply, it wouldn't be able to go across very quickly. And we want it to go quickly, because the quicker it goes, the more we can absorb. Do you understand? Otherwise, we're going to waste it through feces. Okay, so that's the first thing. Very thin cell walls. Okay, sorry, not very thin cell walls. Very thin tissue or layer, or epidermal tissue. Okay, it needs to have a good blood supply. Also very important. Okay, it needs to have a large surface area, so that's why it comes up and across. Okay, it's also got to have the Bremer gland, for instance, it makes it moist and an alkaline system, right? So that all these enzymes can take place, right? It's got to have the crypts of Livercoon, which is there to replace old and worn out cells. Okay, those things are very, very important. It's also got a thing called a lymph drain, right? Which actually takes all the things that cannot go into the red blood cells, into the veins and arteries. It goes into the lymph, which is going to make it easier. It's too big, so your fatty acids and that goes straight into the lymph vessel. Right, so let's have a look if I know what I'm talking about, which I know I do because I put the notes together. So of course I know what I'm talking about, right? So here we go. Touch. That's it. Let's go. The structure of the villi is very specific. Has to be specific. Okay? Everything has a specific thing. Okay? Firstly, it's a great number of them. Can you remember I made lots and lots and lots and lots? The more there are, the greater the number of, or greater the surface area. The bigger the surface area, the more those, the stuff that needs to be absorbed comes into contact with them. The less there are, the less time they get into contact. Right. Okay? So there's got to be lots. There's an increase in surface area, which is very important, as I was telling you. Right? Then, absorption in the small intestine. This normally happens in the small intestines, right? In addition, the villi also have their own projections. In other words, the villi comes out and they come out a little bit more. So each one is a little bit even more in detail. So it creates more surface area. Right. Okay. Then, those little projections are called microvilli. So they're even smaller. Okay? Even much smaller than that. Okay. Now, there are many microvilli increases the surface area, which we told you again. So have you noticed how surface area is the biggest thing in this whole thing? Okay? It's the biggest one. Okay? The microvilli contains epithelial layers. Remember what I said? That's thin cells. Okay? Epithelial layers, which is also called, right, which is also one layer thick. Okay, it's got to be one layer thick, and the food can pass through them very, very quickly. Very quickly. It's very important to understand that. So the quicker it goes through, the better it is for us. Okay. Then, the blood capillaries, which is also, the blood capillaries in the villi are very close. Okay, they're very close. The closer they are, the better. So that the stuff that we're absorbing doesn't have to travel a long distance to get onto the train, for example. It's as they come through, they're on the train and gone. That's how quick it is. The quicker it is, the better. Okay? So the blood system has got to be very close to it, right? Very close to the epithelial system. The epithelial cells, right? And then the epithelial cells, as I said, the closer it is, the better. And it branches out quite nicely. So when the blood comes in there, it goes close and it branches up close to it to make sure that it's very close. So let's see. Increased surface area, big blood supply, very thin cells. That's what makes them very good and adapted to their cells, for their function. Very important. Right. So that there is the question answered quite nicely. Now, next question. Where do most of the fat digestion, here we go, where do most fat digestion occur in the body? Fat digestion. Now, this is a good thing because I didn't say absorption and I didn't say just breaking down. I said both. Okay, remember that most of the fat gets broken down inside your stomach. You remember the hydrochloric acid and all that comes along, so it gets broken down there physically, and then it gets put into the small intestines where absorption takes place, and more amylase and all of that gets, not amylase, lipase gets put in and gets broken down, right? So where does it take place? It first takes place in the stomach, as I said, but the absorption takes place in the small intestines. Nice, simple, easy question, right? You just got to try and put one and one together. It's not too difficult. I know you're fine with that. Next one. Describe how, so you've got to tell me something. Describe how the small intestine is adapted to perform its function for absorption. Now, hold on. Don't you think that this sounds very similar? Hey? Sounds very similar. So, Luni, tell me a little bit. Let's see if you can answer this one because you're so smart. Right? I want to know how the small intestine is adapted to suit its function.
What? It's because it's small and long.
Okay, so there we go. It's long. I like the long part. Okay,
Oh,
the longer
not
it
the
is,
small part.
the better, isn't it?
Yes.
Okay. What about the inside of it. What does it have in it? I was just talking about it. You see what happens when she doesn't concentrate.
No.
Okay. Gotta love it. The villi.
Oh, yes.
Ah, it's got that.
Okay.
What does it want to do? It increases the surface area. Okay, and it absorbs. It's got a very good blood supply, and it's got all the protease and amylase and the what's that other one? Lipase. All of those things are there to help it do its function. So let's have a look at what I've put here, especially for you. Okay, first of all, the absorption surface must be large, right? So that's why we've made it nice and long. Okay, so it's large. Okay, it is thin and close contact with the substrate. That's why it's so small. Okay, it's not, the small intestine is not made nice and thick, because if I had to stick food down there, right, all this food in the middle here is not going to be touched. So what we do is we make it thin, and all the food that's in here is going to be absorbed quite easily. That's why it's the small intestines, even though it's the longest one. The large intestines is just water, gets absorbed quite nicely. Okay, small intestines thin but very long, bigger surface area. Right, so that's that one. It must come into contact. Well, it does. It makes it easier to come into contact with all the stuff, with all the substrate that we are being absorbed. Okay, so it has that. Then it is 7 meters long, as I was saying to you. Nice and long, 7 meters. Can you remember? Luni, how long is a blue whale's?
4 point something kilometers.
4.8. Oh, do you know how long that is? I would die if I had to run that. Hey?
From here to where?
4 kilometers.
Yeah.
Did you ever run long distance at school?
No.
You know athletics track? From start, where you started, you run right, run and back. That's 400 meters.
Oh.
So think how many times you got to run round that to find the 4Ks.
It's fine.
It's too long. It's very long.
Very.
Right. Remember, it's got the folds. The walls have folds in it with villi. Very simple, right? Which contain microvilli. That's the big one. Microvilli to create a larger surface area. Surface area is very important in this, especially with the small intestines. Very, very important. Of course, it's got columnar epithelial tissue, and it's only got one layer of it, so that it's nice and thin. It can absorb nicely, right? There we go. And then it has the system. It's a very cool system. Okay, it has a transport system called capillaries and lacteals. Okay, now watch carefully. Let me just give you a quick thing about this. We've got the villi coming up, right? We happy with that? We got the small, let me change color here so we can see what's going on. We've got the blood system coming in, right? And it does that over and over and over and over, and it comes back down and out. That's it. Nice and simple, quickly, am I right? Okay, and then I'm going to choose white if I can find it. Okay, it's got a lacteal coming in up and down, a lacteal coming in to take the proteins and lipids and all of that. That's roundabout what it looks like. That's a quick draw. You need to know how to draw this, right? So it's got one of those to get everything that we need, right? Now, what else does it have? Villi move with the aid of muscles, so that it moves, so it can move the stuff around, so it can actually absorb a lot quicker. Okay, needs to be able to move, and remember the peristalsis movement also does it. As the muscles contract, the villi are going to move out of the way. Okay, that's the whole point, or that's what makes the small intestine so important to us, and how it helps with absorption. Hey, Luni? We cool. You understand that, my sweetie?
Yeah.
Okay, which organ plays a major role in assimilation? Okay, so Luni, what do you think? Which organ plays a major role in assimilation? And I want you to think about just right hand, big.
Right hand big. The heart.
No, right hand,
Right lungs.
big.
Liver.
The liver. Well done. Wow, Luni, that was amazing. I can't believe you came up with that answer. Right hand big, that was the clue, and she comes out of the blocks flying with the answer. Okay.
You know how I was saying the heart?
Wow.
Because you showed me the 2 ribs, and then you showed me the lungs, and
The
then you
lungs,
said the
yes.
one is smaller than the other.
Is right. Yes,
Yes.
so
Okay.
what I've done is the liver. Now, what I want to do, I'll explain to you as soon as we come back, right? Because I think I need a break. As soon as we come back, I'm just going to give you a little bit about the liver and what it actually does. Right. So, Luni,
Yes. Stomach. And I will see you after the break.
Stop.
Hi, this is my new friend, my other friend. See, I told you this was too much. This is Livy, the liver,
Livy the liver.
with the gallbladder that has bile. Someone asked me what's inside. It's bile. So Livy has a gallbladder, and inside is bile. Can you please not laugh? I have friends. What's your problem? Don't you have friends? Okay, no, it's time to teach the children. Now they're gonna think we're going crazy.
Okay, she's lost it. She has lost
I haven't. I need friends.
it. Right. So I was telling you before we went on a break that we need to have a look at the liver. Right. Now, the liver is very important because everything goes from there to the liver first. Okay? Because the liver is the thing that detoxes you almost. It's a part that protects you. It breaks down things like alcohol. It breaks down your drugs. It breaks down your hormones that you're not going to use. So it's very, very important. Okay? It's also where you find your thing called insulin and glucagon, right? And we need to look at specific things. It's very important. Your liver is the first thing that it's going to go past to make sure that everything's fine. And it helps make things absorb a lot easier. So your liver is very, very important with, of course, assimilation. Right. Now, I did that so you couldn't see. Right. Now, what I want to do is I want to go through your challenge question. Now, I was trying to hold Looney back during the break because she said she wanted to do the challenge question for you. And she said that she's better than what I am. So let me see
what are these lies you
Never.
are telling?
I would never lie
What
to
are
you.
these lies you are telling? Hi.
Okay, Looney. I know that our viewers have come to help you with this question.
They have?
Right? Now, let me hear what they said about this. Remember, the question was, describe the process of digestion, absorption, and assimilation of carbohydrates.
For some strange reason, I
Sorry?
can't see the challenge question on our Facebook page. So you can do it.
Is there no challenge question on the page?
It's a reason. It's not strange. So I'm told to say.
That is not
It's
good.
a valid reason. Yeah.
It's never a good reason. Because let me tell you this.
We apologize.
While I'm trying to teach you, Looney's like this, and she's looking at that book, and she's giving it everything to you guys. And she hasn't posted the challenge question.
Hi. What is this blame game now? No,
You got to. It can't be me.
don't do that.
Okay, let's have a look at it. First of all, we need to have a look at the first thing, digestion. Okay, so we need to have a look. Digestion is how we take in, how we take in the stuff. Or should we say how we take in carbohydrate, what we do, okay? How we take it into our body and take it in and get rid of the rubbish. Okay, so we need to have a look at that. What ways do we have? We have absorption, we have assimilation. Those are the things that we're looking at. Okay, so digestion in full. Firstly, if I'm not mistaken, we're going to take the stuff and we're going to put it in our mouth, the carbohydrate. And what are we going to do, Looney? When I take a piece of spaghetti, let's say spaghetti, right, and I put it in my mouth, what's the first thing I do?
Me too.
I chew.
Yes.
Nice. Now let me ask for the big life science word.
For chewing.
Yeah, for chewing.
I do not.
For this.
I don't know it.
Come on, Looney.
Life sciences word for chewing.
Yes.
No, man. How am I
It's
supposed
called
to know?
masticate. See? Even I know it.
Come on. Jeez.
Yes. So we first start with mastication. And mastication, you've got this funny thing. They call it the most inquisitive muscle in your body. It's called your tongue. Because hurt something in your mouth and your tongue will always find it. Have you noticed? If you've chipped your tooth, your tongue
it's
always
all-
goes to that
yeah.
tooth. It's irritation. Right? Am I right or wrong? And yeah, we
You're
know this stuff.
right.
Yeah, they call it, I promise you go to a
It's
dentist,
the what? The most curious?
the most inquisitive muscle in
inquisitive.
the body. Right. So what it does is that tongue takes this food and it starts moving it to the teeth, right, over to the side. Sometimes it doesn't get out the way quick enough and it gets bitten, right? Okay, but it starts mixing the food with saliva. And what does saliva have in it? It's got amylase. And that breaks down starch, right? So we start there already. And it churns it and it makes it into a bolus, right? Once we've got into a bolus, we swallow it. And as we're taking it down, we're putting it through the small little pipe. And this pipe helps with breaking, still chemical digestion, by squeezing it. So the muscles contract antagonistically, rhythmically. Or should I say, the antagonistic muscles contract and relax rhythmically to each other. So this one contracts while this one relaxes, and then this one contracts, and as that one's contracting, this one relaxes. And it pushes the food all the way down, like you push out your toothpaste out of your your toothpaste out of your, what's a toothpaste in your holder?
Toothbrush.
No, the holder of the
Holder.
toothpaste.
Aye.
You see, the toothpaste holder, you squeeze it
The
up.
tube,
The tube, that's what I'm looking for. Right. So that's how you push it out, right? So we do that. And as it's doing that, it's actually still mechanically breaking down everything. Then we get put into the stomach, right? What does the stomach do? The stomach churns and it breaks and it turns and it squeezes and it does whatever it needs to. It does the whole job, you know, that Yaluni? You know which one I'm talking about, where they give it the, it's a dance, the job, and it breaks it all down, and it makes it into charm, right? But remember that enzymes work at specific pH levels, right? And those pH levels are very important because the amylase works at a alkalinity pH, but in the stomach, the minute you put it in there, they stick in this stuff called hydrochloric acid. And what's it going to do to the enzyme? It's going to destroy the enzyme. So it destroys the amylase enzyme. Okay, once the stomach is finished with the stuff, then it pushes it down through that sphincter into the small intestines, right? In the small intestines, you're going to start throwing in the stuff called pancreatic juices. They're going to throw in bile, and they've got the Bremmer's gland that also secretes a alkalinity substance to start making everything alkaline, right? And while it's in there, the amylase that gets added in again, right, that starts breaking it down even further from disaccharides into monosaccharides, right? Because it's polysaccharides when you put it in. You chew it down, amylase makes it into disaccharides. You swallow it, goes down to the bottom. You're going to get to your small intestines. From the disaccharides, going to make it into monosaccharides. And when it's there, what happens is the villi, right, creating a large surface area, starts absorbing this broken down or monosaccharide stuff and takes it into the blood, takes it all the way to where it's needed, and that's where it starts getting assimilated. With the stuff that we're not needing, goes all the way through, gets put into the large intestine. Large intestine, remember, you're always drinking water, so the water's there, the water gets absorbed nicely, and we're left with feces. And what do? We get rid of feces because we don't need it. That is the whole digestive system of carbohydrates. Now that was just me talking to you. Now that's not me sitting thinking, okay, I need to do this, I need to do that. That was just off the cuff of my head thinking about it. So you guys need to know how to do that, but you need to know it in more detail. Okay, I know that you might think I'm mad, but standing here talking to you, it's very quick to talk. To write it down, you know more. It's much easier. Okay, so let's have a look.
Someone wants to try?
Yes.
Matimba malulek.
Let's hear what you've got.
Digestion is the process where huge molecules are broken down into smaller ones.
Very nice.
And digestion takes part in the stomach, and the type of digestion is chemical digestion. Absorption is the process where the food passes through the wall of the small intestine into the blood system, and it mainly takes part in the small intestine. And then it goes to learning assimilation. I'm smart.
Nice. Very nice. The only thing is, remember, you're missing the most important thing. And the most important thing in this is that they gave you what they want to go through digestion. They wanted carbohydrates. So you need to bring in those enzymes called amylase. Right. Very important. Let's have a look at it. Here we go. And we're going to start from the beginning. Okay. Should I change the color? Huh? We've had yellow all day. Let's go to pink because I brought John on, so let's go to pink for girls. Hey?
Okay. It's fine.
It's fine. Oh,
Yeah.
come on, help me out here. I'm trying to get you in a good mood.
I don't really like pink.
You don't like pink. Green.
Okay, that's fine.
Okay, green. Here we go. We've got green. Digestion begins with the mouth. Yeah, that's a simple part because digestion can't happen without the mouth. Okay, so we've got the mouth. Mastication is what, Looney?
Chewing.
Good girl. This is the process where the breaking down of food into smaller particles so we can swallow it, first of all. And, you know, if you've got a big thing and you break it down, I mean, if I have something this big, okay, and I can put little enzymes here on the side, it's going to take a long time to break it down. If I took the same particle and I broke it up into little pieces, right, and I put little particles around each and every one of those, have you noticed how there's more surface area to start breaking down for chemical digestion? That's why we break it down into smaller pieces. First and most important thing. Right, so we're breaking down the food into smaller pieces. Right. Then salivary glands secrete amylase. Amylase, very important because they asked for carbohydrates. Very important. Got to make sure you know your enzymes, right? Then it begins the chemical digestion of starch, right? Amylase plus starch equals dextrin, which is dextrin and disaccharides. Dextrin is just another big word for what's name? For carbohydrates, right? So there we go. Now we've broken it up into disaccharides from polysaccharides. That's what you call it, right? Then the tongue forms the food into a bolus, as I said, remember, so that we can swallow it. Okay, the mouth, the tongue pushes it to the back of the mouth so that we can swallow it. It goes down the esophagus, right, with that movement called peristalsis. Guys, please do me a favor, seriously. When somebody asks you, what is peristalsis? Okay, the minute if I asked you or anybody that I know, what is peristalsis, the first thing they do is this. Right. But how are you going to write that in a test? Okay? Well, this is peristalsis. So what you're going to write there is, if you look at me during the test, this is what peristalsis is, full stop. Never going to, you need to be able to say, peristalsis is the rhythmic movement of antagonistic muscles moving. Okay, down, pushing a bolus down. Okay, so that's what it is, roundabout. Okay, so it does it via peristalsis. Okay, here we go. Strong muscles contract. Some muscles contract while other muscles relax, pushing the food down. Okay, there we go. Strong muscles in the stomach contract. Okay, it contracts and it goes through that jive, you know, that jive, and it moves everything around and breaks it all up. Right, that's it. And we adding, that's all happening in there. And the process is also called peristalsis movement, right? So it occurs, we add in the stuff called hydrochloric acid, right? That hydrochloric acid stops the functioning of amylase. Remember the pH level. Very, very, very important. Okay? Then, when it's about to leave, you call it chyme. Okay? Remember it was a bolus when we swallowed it. Now it's chyme in the stomach. We send it down to the small intestines. Have you noticed how it's actually quite long, huh? We send it down into the small intestines. When it's in the small intestines, peristalsis movement moves it further and further along. Please don't forget that. It's in the first part of it, so it's a duodenum. Okay, we're going to add gastric juices. Remember, the gastric juices come from the stomach. Okay, and we're going to add things like pancreatic juice. We're going to get in the liver. We're going to have a look at the gallbladder, where we get bile. Bile's going to be added in. Okay, and all of these things are going to start going into the small intestines. Once it's in the small intestines, the amylase starts breaking down the disaccharides into monosaccharides. Okay, monosaccharides is simpler. Think about it: poly, lot; di, two; mono, one. So we're going to go from polysaccharides, lots of it. We're going to break it down into what's the name? A disaccharide, and then we're going to break it into a monosaccharide, a more simpler complex. Right, compound, or should I say. Okay, the monosaccharides, there we go, enter the villi via the microvilli. Then the glucose, because remember it's got glucose in it, that's what the starch has. The glucose enters the blood capillaries of the villi. Okay, now once it's in there, that is just absorption. Remember, Then it gets taken into the blood system. The blood system takes it past the liver. If there's too much sugar, we're going to add insulin so that we can store some of it. If we need that sugar, we're going to take it to the muscles that need it or wherever it needs it, and it's going to be absorbed into, or it's not absorbed, it's going to go through assimilation, which means it's going to be pulled in to everywhere else. Right. That, you can't tell me that that wasn't cool.
That
Lumi's
was
just going
awesome.
like this, and it's like gone straight over her head.
No, man, what are you
No
talking
ways,
about?
of course not, Lumi.
Can we take one question?
Sure, quickly. We've got 30 seconds.
Abongile, can
Yeah.
you please describe how the small intestine is adapted to perform the function of absorption?
I did explain that. It was that one where I said
Maybe
exactly
they
how
were in the
increased large
bathroom,
surface
they weren't
area.
listening.
Yeah, it was definitely increased large surface area and microvilli and blood supply, very thin walls, right?
Okay,
All of that's very
okay,
important.
okay. Now,
Right.
where does most of the digestion occur in the body?
In the
In
last
the
small
in the
intestine.
small
But
intestine.
Rooney,
It's
it is
in
a small
grades.
intestine, but we need to go. Sweet.
Yes, I know.
We need to go and I'm going to miss you guys.
Okay, from Lou, stomach, Livy, gallbladder plus bile, and Looney. Bye, guys. Thank you so much for tuning in. We'll see you next week.